Myself Pragati Chauhan, and today we learn the topic sorting lists in Python using nested loops. What is sorting? Sorting is the process in which we arrange elements in a specific order that can be either ascending, that is from smallest to largest, or descending, that is from largest to smallest. And it can be based on any particular criteria such as numerical value, alphabetical order, or any other property. So that's about the sorting. Now let's take an example. Here I have listed a list named numbers which contains the number 5, 3, 8, 1 and 7. Here as you can see that 5 is bigger than the 3 but 3 is lesser than the 8, and then 8 is greater than the 1 but 1 is smaller than the 7. So there is no specific order between these numbers. But if we arrange these numbers in the ascending order or in the descending order, our list will become sorted list. Now move forward. What's the purpose of the sorting? Sorting plays a very crucial role in Google search because when any user enter any query on the Google, there are billions of the pages available on the Google, but Google gives you the most relevant result at the top, and that's where sorting algorithm help. Basically Google sort all the billions of the web pages to show the most relevant result first, and then these sorted pages also allow us to give the result as quicker as possible, and it also helps in the organizing the data. Now let's take a look at the algorithm of the sorting. Here I have taken a list containing numbers 5, 3, 8, 1 and 7. And now we'll arrange these numbers in the ascending order. So for arranging these numbers in the ascending order, we'll take first two pairs, that is 5 and 3, and we'll compare them. And when we'll compare them, we'll see 5 is bigger than the 3, so we'll swap their position. Since we are arranging the numbers in the ascending order, so we want the largest number at the end of the list. So among these two numbers, whatever the number will be bigger, we'll swap their position. So here 5 is bigger than the 3, that's why we'll send 5 to the position of the 3 and 3 to the position of the 5. And after that swapping, our list will become 3, 5, 8, 1 and 7. And in the step 2, we'll take another pair, that is the element of the second place and element of the third place. And when we'll compare them, we'll see 5 is smaller than the 8, so we'll leave them as it is they are. And after that swapping, our list will become 3, 5, 8, 1 and 7. And in the step 3, we'll compare the another pair, that is element of the third place and element of the fourth place. And when we'll compare them, we'll see 8 is bigger than the 1. So we'll swap their position, and after that swapping, our list will become 3, 5, 1, 8 and 7. And in the step 4, we'll take another pair, that is 8 and 7, and when we'll compare, we'll see 8 is bigger than the 7. That's why we'll swap their position, and after that swapping, our list will become 3, 5, 1, 7 and 8. And now you can see that 8 being the greatest number, and now after that iteration we have got the 8 at the correct place, that is the at the end of the list. Now our next task is that we have to sort the remaining 4 numbers. We have to arrange them in the ascending order. So for the next iteration, we want us the number 8. We'll just compare the remaining 4 numbers. So we'll repeat the same process with these 4 numbers. Now for the first time, we'll take the element of the first place and element of the second place, that is 3 and 5, and when we'll compare them, we'll see 3 is lesser than the 5, so there will be no change and our list will remain as it is that was before. In the next step, we'll take the element of the second place and element of the third place. And since 5 is greater than the 3, so we'll swap their position, and after swapping, our list will become 3, 1, 5, 7 and 8. And in the next step, we'll take element of the third place and element of the fourth place. And when we'll compare them, we'll see 5 is lesser than the 7, so there will be no change. And after that, our list will become 3, 1, 5, 7 and 8. And after that iteration, we have got last two digit, that is the greater number. 7 is the second greatest number and 8 is the most greatest number in the list. We have got them at the end of the list. Now we have to sort the remaining three numbers. Here by default we are getting 5 at the correct place, but that's not the possibility for the every time. So now let's sort the remaining three numbers. In the next step, we'll repeat the same process with the first three numbers. And when we'll compare the first two numbers, when we'll compare 3 and 1, we'll see 3 is greater than the 1. So we'll swap their position. And after that, our list will become 1, 3, 5, 7 and 8. And for the next time, we'll compare the element of the second place and element of the third place. And when we'll compare, we'll see there we'll see 3 is smaller than the 5, so there will be no change. And then we'll repeat the same process with the remaining first two numbers, and when we'll compare them, we'll see 1 is smaller than the 3, so there will be no change. And here we are at the end, we have got our sorted list. We just take two pairs, we just take a pair of numbers in which we compare two numbers, and at the end we have got the sorted list, and that is 1, 3, 5, 7 and 8. Now let's move forward and look at the code of that. In the coding part, instead of going for the whole code in once, I have written the small task here. So we'll perform this task and ultimately we'll get the whole code. So before start the coding, so what we can define a function that is named sorting, and what we'll give as input, we'll give the our unsorted list. And then one thing we can also do is that we can initialize our list, name list, and that will contains the number 5, 3, 8, 1 and then 7. So now we can start our logic part. So for start the logic part, we need to store the length of the list in a variable named n. So for that we can write here is that n equals to length of the list. Here n variable is storing the length of the list, and here that is 5. Now our first task is that we have to access two elements. So for accessing elements, we can use a for loop, and in that for loop what we can do that we have to make ensure that that loop will run for the n times and sort all the elements. So for that what we can do, we can write for I in range n. So that loop will make sure that it will take all the elements for the ones. And our next task is that we need to compare two adjacent elements. So for comparing two adjacent elements, what we can do, we can write another loop inside the first loop, and that will say for j in range, and here in the range part, as we have seen in the algorithm, that after the first element being sorted, in the next iteration we didn't touch that element, and same for this after second iteration we leave the last two element, just compare the starting three. So in the range we can't pass the whole list, so for that we don't want to touch those elements, so for that we can write n minus 1 minus I, and here I will be the value taken as 0, 1, 2, 3, 4. So, and when we'll write that range, that won't touch the last element, that just only take starting elements which are not being sorted. So that's how we have completed our second task, that is saying how to decide next element without using sorted elements. Now since we have accessed all the elements, our next task is that what if element is not being sorted? So if element is not sorted, what we can do is that, so for that we can write that mm, there is a if condition that will check whether the element of jth indices is greater than the element of the jth plus 1. That is saying that if element is not sorted, then what we can do, we can swap their position. So for swapping, we need to send the element of jth indices to the element of the jth plus indices. So for that we can write is that list jth place element, we'll write this, and then the list jth plus 1 element, and for that we want to send list of jth indices to the place of the jth plus 1. So we'll write list of jth plus 1 and then the list jth element. So that is step will do the swapping. Here if the element is greater than, if the first element is greater than the element before that, then we'll swap their position. So after swapping being completed, at the end what we want to return, in the return we want our list back, that will be our sorted list. So what we'll write for that, we'll write return list, and when we'll run this code, we'll see there is no error. Now we need to call the functions to check whether this code is correct or not. So for that we'll write sorting, then the name of the list that containing the element 5, 3, 8, 1 and then 7. And when we'll run this code, we can see that here we have got our list with element being sorted, that is 1, 3, 5, 7 and 8. So now let's summarize the whole code again. Here we have first defined the list name list, and in the variable n we have stored the length n, and for the with the help of the outer loop we have accessed all the elements, and since we want to compare the adjacent elements, that's why we have used another loop inside the first loop. And if the element is not being sorted, we just swap their position. So that's what about the sorting is. I hope you found this video helpful.